type of application that can be used with trig functions in solving right triangles is dealing with bearing. And there's two different methods. One method is going in a clockwise direction from due north. So you always start from due north, and then your angle will open up. Say it's 50 degrees, so the angle will open up clockwise to 50 degrees. So at 50 degrees, you'd be heading in this type of direction. So from due north, 50 degrees clockwise, that would be your bearing. Okay, so if it's, say, it could be 180 would be starting here, going 180 degrees. So you'd be going due south, basically, right? Say at 300. If I say just plain 300 degrees, and that was your bearing, 300 degrees, you'd go off north and you'd go 300, somewhere about there. So you'd going in that direction. You'd be going in this direction. Okay. So it's always clockwise from due north. That's the way it's going. And there is no north-south. It's just understood that you're going from due north. Okay. The second type is going from a north-south line. So it's off of a north-south line. So you always have a north-south line. Here's north, here's south. And then here it will be given in like, it would say from which line you start, and then the degree, and then in which direction. And your directions would be west and east. So for the example that we'll do, it'd be north 47 degrees east. So you'd go from the north side and you'd go towards the east 47 degrees. So this is the line in green that you'd be going. It could be north, say, and these ones are an acute angle. So it's always from a north-south line, and it's always an acute angle going either east or west. So it could be north, say 30 degrees west. So it looks something like this, like in blue. So that'd be like 30 degrees would be right there. So I'm going off of the north line, I'm going 30 degrees, and I'm going towards the west. So that's the direction. That would be my bearing. Okay, so you could have south, going off south, say south at 20 degrees east. So from the south, I go 20 degrees east, and so that would be my bearing right there, going in that purple direction there. And then last one would be, say, going south. My bearing would be south, let's say 56 degrees west. So going from the south, I go 56 degrees, and so to the west. And so that would be the one in green or yellow there, would be my bearing, south 56 degrees west. So those are the two different types. So let's go ahead and do an example for each of these. Okay, so here's an example of the first method. So method one, and how we can tell which method it is based on the bearing that it gives us. So it gives us a 61 degree bearing and a 331 degree bearing. So when it doesn't say north or south or east or west on the bearing itself, then we know it's method one, because it's always assumed that method one is always assumed it's going north. So it doesn't even have to say it's off of north. Okay, so we have two radar stations, A and we have B, and they're on a east-west line, so they're straight across from each other on a west-east line. And then somewhere we have this plane on C, right? So this plane is detected on C. So we have ABC. Then we know from the north line, from a north line, radar station A detects the plane at a bearing of 61 degrees. So if we go over 61 degrees from due north, so this would be north, 61 degrees, we locate it's traveling on that direction. Okay, and then we see that B, let's do blue, on a north line detects the same plane simultaneously, right? It has to be at the same spot simultaneously at a 331 degrees. So I go all the way around to about right there, and so it's this line. Okay, so as you can see, we have a triangle, and we're going to have a right triangle because we know that CAB and CBA are complementary, right? Meaning they add up to 90. Because we know that we're going off, these are horizontal, this green one right here, now it's colored yellow, right? That's a horizontal, a west-east. So that means that from due north, this angle would be a right angle, and so would this one. So if those two are right angles, that means that this angle right here and this angle from right here have to add up to 90, right? Because they're both based off a right angle. Okay. All right, so that means that C would also have to be a 90-degree angle. Okay, because if these two, green and green here, add up to 90, that means there's only 180, right? There's only 180 in a triangle, so that means C would have to be 90. Okay, so we have a right triangle, so we can use that fact that we have a right triangle, and then we know this distance between A and B is 3.7 kilometers. And now we're trying to find just the distance from A to C. So from A to C, so we have a right triangle. We know the hypotenuse, right? So now we go ahead and label our diagram. We draw it out. We sketched it out. We labeled our angles, right? We know that this is 61, and so that means that this would be 29 degrees. And because this is 61, and if I go horizontally, right, that was 90. So in this one, same thing here. If this distance, if this is this blue, right, station B here, blue was 331, to get full circle would be a distance of 29. So there's a 29-degree gap here. So that means this one down here would have to be 61 degrees. And so then we can see they're complementary, right? They add up to 90. Okay. All right, so now we have the hypotenuse, and we're trying to find the side AC, so that's the side we're trying to find. So if we want to put an X there, a variable, right? Now we can pick any angle we want to. We can pick the 61, or we can pick the 29 and write our trig function, write our equation. So I'm going to do sine, because, I don't know, sine, sure. Sine, what would X be? What's the opposite? Because sine is opposite over hypotenuse, because we have the hypotenuse, so that's why I chose sine. Or you could choose cosine, which is adjacent over hypotenuse. So I chose one of both those two because we have the hypotenuse. Alright, so I'll go ahead and do both of them. So we have sine. Sine is opposite. Well, what's opposite of x? That'd be 61. So sine of 61 is equal to x over our hypotenuse, 3.7. Or I could do cosine, which is adjacent. So cosine is adjacent. So what's next to, what's the angle next to x? Well, that's 29. So cosine of 29, right? And those are called cofunctions, right? Sine of 61 and cosine of 29. And that would be adjacent over hypotenuse. So we're going to get the same answer here when we do this. So when we do that, we get our, or you get this side x is equal to approximately 3.2 kilometers, because this is 2 digits, right? 2 here, so on. So there we go. So 3.2 kilometers. And we just multiply both sides by 3.7 on this and on this one. Alright, so there's that example. Here's another one. Looking at a ship that leaves port. So here we have a ship. Okay, it leaves ports on a bearing of north 47 degrees east. So from due north, we're going 47 degrees towards the east, so that'd be to the right at 43 degrees. So we're traveling in this direction for 4 hours. So we're traveling at 4 hours, and we're going that direction for 4 hours, and then we go ahead and say make a stop, right? And then the sail's on to the south. So from once we turn, we're going off a south line, and this way we're going to the east, right, at 43 degrees. So we go east, which is, again, to the right. 43, or, oh, sorry, this one was 47 degrees. 7 degrees, and this one is 43 degrees. So you travel this way 43 degrees. So now that's our bearing. And then after another, oh, the first one's 3.5 hours, sorry. This one's 4 hours. And then they go ahead and stop, and they want to know, okay, how far when they stop right here after 4 hours, how far are they away from port? Okay. So again, we want to go ahead and use to find this distance. So maybe you can't see it, but we're going to have we'll have a 90-degree angle here, and so this would be the hypotenuse, and that's the distance that we're trying to find. So you could label it whatever you want to, but it's going to be the hypotenuse. And so because if this is 47 degrees right here, these north-south lines, right here are parallel, right? So they're parallel to each other. So this distance that we traveled at first for 3.5 hours, this green one, that means these two angles right here are going to be 47, right? Because that's a transversal, and they're crossing two parallel lines. So this is also going to be 47, and 47 plus 43 is 90. So that's why we have a right angle right here. Okay, so we have our right angle, and then we have this triangle, and we want to go ahead and figure out what is this distance between the hypotenuse. So we don't actually have to use trig functions here, because nautical miles is just dealing with distance over time. So distance for this first one in green, I'll stick with green, right? We take 3.5 hours, we times that by how many knots we're going, okay? And that will give us the nautical miles, because knots are just nautical miles per hour. So we know the time, how many hours, and then we want to find how many nautical miles we've gone. And our speed is, for this first one, oh, the speed in both of them is 22. So we times that by 22, and we get 77. So this distance in green, if you want to, you could label this triangle. We could do let's stick with C. Always make the 90-degree C, so then we're all on the same plane here. And this is B. Okay. So from A to C, that distance A to C, which is little b, so this will be little b, b is equal to 77. Now little a is taking how long we traveled there, which is 4 hours, and the same 22 knots. So we travel 88 nautical miles. And now we have a right triangle, so now we can do Pythagorean theorem, right? C squared is equal to A squared plus B squared. Oops, why did I write B squared when I could have write 77? So then we go ahead and square those, then we add them, and then we go ahead and square root both sides. So C is equal to approximately 120 nautical miles. Okay, so they're 120 nautical miles from port. Okay, so on page 527, you have number 61 and 63. Here is number 61. So we have two docks located on the east-west line. So here's horizontal east-west line. We have dock A, let's say dock B, and then they are 25, 87 feet apart. And from dock A, we take a bearing of 52 degrees, 22 minutes. So from a north line, always from a north line, right? Because here they don't say north or south, so that means that's the first method. And we go 58 degrees. So 58 degrees and 22 minutes. And then we stop. And then we go From dock B, I guess you're locating a boat, something. Oh, the coral reef, sorry. And then from dock B, we go 328. So always from due north on method 1. So we go 328. 328 degrees and 22 minutes. So that's nice they use the same 22 minutes. So we're going in this direction. So just like before, right here, because this is horizontal, that means we have 90 degrees there and 90 degrees here. And so we can go ahead and notice that this gap that's going to be filled is 58 degrees and 22 minutes. So so that means this one so then we're, let's see, sorry, not 58, sorry. Let's find out how many 22 minutes is. So 22 minutes, find out how many degrees that is, because we wanted to convert these to decimal degrees. So we divide that by 60, because in 60 minutes there is 1 degree, right? So we go ahead and divide that, and that's going to give us degrees. And so we're going to take 22 and divide it by 60. So that's approximately 0.37 degrees. So that means that basically we have a right triangle. So let me just redraw this. So we have a right triangle. Go ahead and label that C. This is B. This is A. So this distance here is 58.37, and this distance all the way around to this point was 328.37. So if I just go ahead and take 360 and minus that, that's 3163. So this distance from here to the 90, or to the north line, would be 31.63. So that means this one down here is the 58, because that would complete the 90. 58.37. Yeah, 0.370. This right here is not a 36, it's 31. Okay, and then this one would be the 31.63 degrees. Okay. All right, and then we're trying to find this distance from A to B. So that would be little c. So that's our hypotenuse. So we could do sine or cosine. So sine, are we trying to find that, or we know? No, we know that distance. Sorry, we know that distance. The hypotenuse, 2587. Yeah, 2587. And so we can use sine or cosine because we know the hypotenuse, right? 2587 equals 2587, and we're trying to find the distance from A to the coral reef. So from A to the coral reef, so that'd be little b, little b, little b. So b in relationship to the 31.68 is adjacent, so this one is adjacent, so that'd be cosine. So 30 cosine of 31.63, sorry, 63. And so that this one would be opposite. So that'd be sine. So that's sine of 58.37. 0.37? Yeah, 0.37. Okay. So then we multiply both sides by 2587. 2587 on both equations. 87. And then so we get our answer as distance from point A to the coral reef is approximately 2,203 feet, because we're rounding to 4 because there's 4 here, and that's why I put 4 here. Okay, so there is number 61. Okay, number 67, we're looking at the distance between two cities, Winston-Salem, North Carolina, and Dansville, Virginia. So the bearing is north 42 degrees east. So we start at one point. I'm thinking the Winston-Salem. And from there, going off a north line, we're going 42 degrees towards the right because that's east. East is to the right. So we're going this direction to Dansville. So Salem, Dansville is in this direction. And the bearing from Dansville to Goldsboro, North Carolina is south. So we're going from here on a south line now. So these two are parallel. North line and the south line are parallel. And we go in a probably another eastern. So this one is south 48 degrees. All right, because remember these two are going to have to probably add up to 90 because we want a right angle right here. So that's kind of why it has to equal. That's why it has to open up to the east, as well as 48 degrees, because 42 and 48 is 90. Okay, so it goes that direction to this place at Goldsboro, North Carolina, and then we probably want to know the distance between Salem, Winston. So A to B. We're going to know that direction. So here's C. So this is little c. This is B. And this is little a. Okay. You can label them whatever you want to. It doesn't really matter. Okay. So we know we have a right triangle. Now it's probably going to give us some type of distance here. Yeah, we're traveling at 65 miles per hour for 1.5 hours. So let's assume that it's constant, right? And you're going straight at 65 to when you get there, you're going 65. So we kind of have to assume that in order to find out, what's the distance between here, because we want to do some math in that. So from A to C, we want to go miles and how many hours, and that will give us our distance, right? The speed equals distance over time. So if I want to find the distance, I'll take my speed and times that by time. So the distance from A to C is our speed, which is 65 miles an hour, and how long we go, 1.1 hour. So we get 71.5. So there's that distance. So if you want to, you could draw another triangle. So this is 71.5. Then from Dansville to Goldsboro, from C to B would be going, are we going 65? Yeah, in both cases we're going 65. On this one we're going to take 1.8 hours to get there. So we multiply those, so we get 117, so 117 miles. And we probably want to find this distance C, right? So we can do Pythagorean theorem. Take 7.15 and square it, and then add after we square 117. So we square both of those, then we add them, then we square root to get our answer of 140 miles. Okay, so that's number 67.